The DMAIC cycle consists of 5 sections: define, measure, analyse, improve and control. The define phase is used to identify what the problem is within the current process, where the opportunity for improvement is, what the project goals are, and what the internal and external customer requirements are. The measure phase consists of collecting data on the current system to quantify process performance. This is then used in the analyse section to determine the root causes of variation and poor performance. These root causes can be narrowed down or prioritised to establish improvements which address and eliminate these root causes. Finally, the control section ensures that the improvements made to the process are maintained and quantified. To assist the DMAIC cycle, an array of tools can be used, such as process flowcharts, SIPOC, and value stream mapping. To assist the DMAIC cycle, an array of tools can be used, the first of which is an Ishikawa or cause and effect diagram, which identifies any causes for a specific event, such as a defect. A process flowchart is a map of a process that a team is working on. It is meant to show what is happening rather than what is meant to happen during a process. A Pareto chart is used to graphically summarise and display the relative importance of the differences between different groups of data. Histograms are great at showing how capable a process is. Adding specification limits on top of a histogram graphically shows how many objects are within the limit, revealing its capability. A control chart is a graph used to study how a process changes over time. The DMADV cycle consists of 5 stages: define, measure, analysis, design and verify. It is important to note that the DMADV cycle is in more ways than not similar to the DMAIC cycle, as it requires the same information on the existing process to be implemented. The main difference is that it requires a different toolset and different methodologies to design a Six Sigma performance level process. Define. Define the goals of the project, the purpose of the process, service or project, and set realistic goals. Measure. Measure factors critical to quality. Identify the critical design parameters. Design scorecards that will evaluate the design components more important to the quality. Assess the production process capability and product capability. Analyze. Develop design alternatives. Identify the optimal combination of requirements to achieve value within constraints. Develop conceptual designs. Evaluating, then selecting the best components. Design. Design detailed and high-level design for the selected alternative. Verify. Is it acceptable to all stakeholders? Expectations will be confirmed. Deployment will be expanded. Lessons learned will be documented. Which is best for your organisation? If your organisation is new to the Six Sigma methodology, the answer is almost always Lean Six Sigma. This will focus upon improving your current processes and on giving your personnel the knowledge to progress into design for Six Sigma, which is a fundamental requirement.